For as long as humanity has looked up at the night sky, the moon has been a constant companion, a silent observer of Earth's history. Yet, for all its beauty, we have always regarded it as a barren, lifeless world, a place of dust, rock, and cold emptiness, with no atmosphere to sustain life, no oceans to reflect sunlight, and no sign of water. But in the last few decades, our perception of the moon has begun to change. Hidden in the deepest, darkest corners of its craters, within the very soil beneath our feet, scientists have discovered something remarkable: water. A substance so fundamental to life, yet once thought impossible to exist on the moon. But how did this water arrive? Was it always there, or did it form after the moon was born? To answer that question, we must journey back into the moon's ancient history and unravel the mysteries of its formation and evolution. At first glance, the moon's surface seems the very definition of desolation. Without an atmosphere to protect it, the moon's surface endures the full force of the sun's radiation, and temperatures range from blistering heat during the day to bone-chilling cold at night. Without any protective air or liquid to moderate those extremes, water in its liquid form seems utterly impossible. In fact, water, by the familiar definition of lakes, rivers, and oceans, cannot exist here. The moon's lack of atmosphere, its low gravity, and the hostile conditions make it a seemingly dry world. And yet, in the most unlikely of places, hidden in the shadows of its craters, scientists have found signs that the moon is far more complex than once thought. With no air to speak of, the moon cannot trap water vapor like Earth does. The absence of a thick atmosphere means that any water molecules present would either freeze or quickly vaporize and escape into space. Without protection from the sun's intense radiation, liquid water would have a hard time existing in any stable form. So, how did the moon acquire water, and why does it remain hidden on its surface in such elusive ways? For decades, the moon was thought to be bone dry, but the tides began to turn in the 1990s with the launch of several space missions, such as NASA's Chandrayaan-1 spacecraft. In 2009, this mission brought forth a groundbreaking discovery. Using a tool called the Moon Mineralogy Mapper, M3, scientists detected water molecules in the lunar soil, particularly in regions that were previously thought to be inhospitable. These water molecules weren't present as large bodies of liquid, but rather in the form of trace amounts embedded in the moon's soil and minerals. Even more intriguing, however, were the discoveries made in the permanently shadowed craters at the lunar poles. These regions, which never see sunlight, remain at near absolute zero temperatures. It is here, in these cold, dark pockets, that scientists found significant deposits of water ice. Trapped in these hidden craters, water ice could persist for billions of years, untouched by the sun's rays. And it wasn't just remote spacecraft that found evidence of lunar water. During the Apollo missions in the 1960s and 1970s, astronauts returned with samples from the lunar surface. These samples, when analyzed back on Earth, revealed signs of water absorption within the moon's rock structures, suggesting that water was indeed present, though in much smaller amounts than on Earth. So, how did water come to be on the moon? How did a world that was once thought to be dry and barren become the home of water ice, molecules, and hydroxyl compounds? Scientists have put forth several theories to explain the moon's hidden water, and each offers a fascinating possibility. One of the most widely considered theories is the idea that comets played a key role in delivering water to the moon. Comets are icy bodies that travel through the solar system. often containing a mixture of water ice and rock. When these comets collide with the moon, they would release their water vapor, which could then be trapped in the colder, permanently shadowed regions at the lunar poles. Over billions of years, the relentless bombardment of the moon by comets would have delivered significant amounts of water, much of which would remain locked in the dark craters, never to evaporate or escape due to the extreme cold. While this theory is widely accepted, some scientists question whether comets alone could explain the amount of water discovered on the moon. Could there be another, more constant source? Another theory suggests that solar wind, the constant stream of charged particles emitted by the sun, may also be a contributor to the moon's water. Solar wind is rich in hydrogen, specifically protons. These particles interact with the oxygen-rich minerals found in the moon's surface, creating hydroxyl molecules, OH. Over time, these molecules can combine to form water. Unlike comet impacts, which are intermittent, solar wind constantly bombards the moon, and over billions of years, it could have slowly deposited small amounts of water throughout the lunar regolith. This process, known as hydrogen implantation, would mean that even in the absence of large-scale impacts, the moon has still been accumulating water. The question remains, how much water has been accumulated this way, and can it be extracted for future use? A third possibility points to the moon's ancient volcanic past. Though the moon is geologically quiet today, it was once much more active. Early volcanic eruptions could have released water vapor from the moon's interior into space. This vapor could then have been trapped in the lunar surface over millions of years, perhaps explaining some of the water found in the regolith and the deeper, mineral-rich layers of the moon. While the moon is no longer volcanically active, the legacy of these eruptions could still be felt today, with traces of water molecules locked in the mineral-rich rocks and soil. Although these theories offer exciting possibilities, many questions remain. How much water is actually on the moon? Is it in the form of ice, hydroxyl, or a combination of both? And most importantly, can we harness this water for future missions? As we continue to study the data from missions like the Lunar Reconnaissance Orbiter and the upcoming Artemis program, we are one step closer to answering these questions. The discovery of water on the moon is just the beginning. The real challenge now lies in understanding how to extract, store, and use this precious resource. Water could become a crucial element in humanity's long-term plans for lunar bases, providing a sustainable resource for astronauts and paving the way for future exploration of the solar system. Water on the moon could unlock the next chapter of human space exploration. NASA's Artemis program, which aims to return astronauts to the moon by the mid-2020s, could rely on this lunar water to support long-term missions. If we can extract and utilize water from the moon, it could be used for drinking, growing food, and even converted into oxygen for breathing and hydrogen for fuel. This water could make the moon a vital resource for missions to Mars and beyond. Once thought to be a dry, lifeless world, the moon is revealing itself to be a place of incredible potential. Water, one of the most fundamental building blocks of life, was hiding in plain sight, waiting to be discovered. As we prepare to return to the moon, the lessons we learn here will shape the future of human exploration. The moon may not be the final frontier, but it is quickly becoming the first stepping stone in our journey to the stars.